Hey folks, so in this video, we're going to discuss about finite element analysis. So my friends, in order to basically describe finite element analysis, I'm going to give you some of the brief insiders. But by the way, if you have not subscribed to our channel and if you have not basically hit on that bell button, or if you haven't liked it, then please do it. And in order to to get more updates about our channel, about all stuff about engineering optimization, and even about Tableau and data science, and even about stuff in the fields of computational fluid dynamics and stuff. Please do subscribe to our channel. So my friends, I'm your friend, and I'm your fellow aerospace engineer, Master Chintamani. Basically, I'm an aspiring gynecologist. So, okay, let us start with our definition of finite element analysis. So basically, guys, finite element analysis is a methodology, guys, for methodology, which is used in mathematical modeling and engineering, guys. Which is a methodology, guys, which actually breaks and so-called object, guys, while studying it, and which is basically known as the discretization. So, guys, basically, finite element analysis, what that means is that in order to basically study an object, guys, let's say any object like any substance, or rather any material scientific conceptualization, guys, in the engineering domain, guys, maybe the problems of the heat transfer, structural heat transfer, and even even of mass transfer and stuff, or even some of the problems, guys, related to the combustion. Guys, all those problems, guys, are basically solved, by the aid and assistance of the finite element analysis, or rather, there happens to be a methodology, or rather a code, or rather an algorithm, which is basically even known as the FEM, finite element method, and basically the analysis, which is performed, guys, on an object and stuff, is known as the finite element analysis. Basically, guys, what that means is, guys, it's a way of studying a particular object, guys, by basically assigning some coordinates and some values, into a particular object, guys. Like, let's say, you gotta study a cylindrical reservoir. Then, guys, what FEM does is that, FEM basically, has that capability to break down that so-called cylindrical reservoir, guys, into smaller pieces, guys, with the inner assistance of discretization, or rather, it's known as discretization. Guys, once that discretization, takes place, guys, assignation of the coordinates such as x, y, and z, guys, basically, takes place, guys, and each and every particle, or rather each and every piece, which is basically divided, guys, is given and is assigned a coordinate, and guys, then each and every piece is, guys, and analyzed in a greater degree of precision and detail, guys, and which is basically known as discretization. Now, guys, the discretization in the finite element analysis is even used, to study the boundary level problems, guys. And that too, with the that too with real-time analysis. And basically, there happen to be two approaches, guys. Two approaches, while studying that, and studying those boundary level problems, which happens to be the approach of Galerkin, and it even seems to be the Rayleigh-Ritz methodology. So, guys, the Galerkin method and the Rayleigh-Ritz method, guys, seem to be two approaches, guys, to basically study the boundary level problem, guys, in a real time. And, guys, what it signifies is, guys, that in order to even like, for example, in order to even perform simulations, guys, of and car accident analysis and stuff, guys, or let's say a vehicular accident analysis and stuff, what finite element analysis helps you to do is, guys, instead of using an actual physical car, guys, for that so-called purpose of testing that car, in which it's accidentally gonna collide to a so-called boundary level, to a boundary, maybe a wall, or maybe another vehicle, or maybe any other constraint, guys, instead of that, guys, what it helps you with is that, guys, with the inner assistance of computer simulation and computer modeling, guys, it basically breaks down that car and even that so-called boundary condition, guys, through the applicability of discretization, guys, and which basically gives you the opportunity to study an realistically accurate simulation, guys, of as to how that car is basically going to collide to that wall, or rather that boundary condition, and number which are the things number which are going to take place, guys, after that. And number once that car, once that car, once you basically opt to analyze that, with the inner assistance of the computer graphics, guys, it happens to be a lot easier, to solve those problems, guys. So that those are the methodologies, in which the finite element analysis, helps you. So guys, instead of going to the actual field and stuff, to perform those tests and all tests, finite element methodology or analysis, guys, helps you to do the same things, guys, with the inner assistance of an numerically high programmable computer software, and through the inner assistance of a lot of linear algebra and mathematics, guys, and you can even opt for modeling that data, guys, and even breaking down that data. And with the applicability of finite element analysis, guys, you can study greater problems, or rather real engineering problems, guys, in real science world, guys, through precision, guys, and it's basically absolutely convenient. And basically, guys, this so-called finite element analysis, guys, as a methodology, was basically institutionalized by Professor A.R. Clow of the United States, and who specialized, in discrete mathematics, back in 1930s. And guys, that was in fact, so-called the era of 1930s, was in fact, the birth of finite element analysis. And guys, it was in those days, guys, that lots of scientists and engineers, from Boeing, and even National Advisory Committee for Aeronautics, guys, the primitive body, or rather the precursor to the National Aeronautics and Space Administration, NASA, guys, used it as a tool, guys, as an efficient software testing tool, guys, to perform greater calculations, greater engineering and technological calculations, guys, about even the manufacturing of even the manufacturing of that aircraft Brabazon, which took place in Britain. And but that is how, guys, finite element analysis, has evolved, from that span, guys, pre-World War II in Europe, and especially in the United States. So guys, as I told you, finite element analysis, basically, gives you that so-called precision, guys, to use that CAD modeling, three-dimensional computational drafting, guys, CAD modeling, guys, to use and break that so-called problem, guys, into pieces, guys, basically in discrete intervals, and which is basically known as discretization. So guys, finite element analysis, works really well, with the computer simulation and stuff. And guys, softwares like TensorFlow and stuff, are used, guys, to perform the analytics, guys, while you basically got to study and problem. And you can study any sort of problems, guys, with the inner assistance of finite element analysis, guys, let's say, and crash testing, or let's say, guys, an engine bird strike, and real scenario, guys, of an aircraft turbine engines bird strike, guys, and all those things are basically performed with the inner assistance of the finite element analysis. So guys, that was just a simple definition or simple insider, which I wanted to give you. And that is about finite element analysis. And in order to know more, guys, please do hit that subscribe button if you have not hit it, and please do share it with your friends in the engineering community and even the MBBS community. So see you, and I'll more updates soon, and see you. Bye bye.